Hey friends, welcome to the academic video for this project. And we're talking about rockets, right? There's all kinds of STEM principles at play, but we're just going to be focusing on just a few in order to get the points across. And it all starts with Newton's third law, which says, for every action, there's an equal and opposite reaction. This should be a relatable example. Imagine you're on a boat or a raft on the water and you jump off. You go one way into the water, but it pushes the boat back the opposite way. It's also how bouncy balls come back up to us. It's why we don't sink to the center of the earth. And it's also how rockets work. See, the goal for a rocket is obviously to go upwards, but when they turn those rocket engines on, they generate an incredible amount of thrust in the downward direction. And we want you to pause this quick video, and given what you know about Newton's third law, see if you can come up with a quick idea about how they work and how rockets achieve liftoff. If you said anything along the lines of, rockets keep generating that downward force until its equal and opposite upward force becomes more than the weight of the rocket, you'd be exactly right. You see, once that upward force does become more than the rocket's weight, that's when you get liftoff. And speaking of liftoff, that brings us to our next topic, which is thrust. Thrust is a very, very important force when it comes to rocket science, and here is its equation on the left. I know it looks a little scary, but you by no means need to memorize it or anything. We just want to show you that it exists. Essentially, all it's saying in our case is how much rocket fuel you have, and how quickly you can speed it up to and burn it is going to lead to a higher thrust. And of course, we have a fun little activity to demonstrate that principle. This yellow balloon represents something with not a whole lot of substance to burn, and even if you burn it quick, it doesn't go very far. This orange balloon represents a ton of substance to burn, but when you let it out nice and slowly, it's not going to go off very far. And finally, this blue balloon has a lot of substance to burn, and when you let it out quick, look at all that propulsion. We're going to be relying on air pressure to launch ours. And pressure, believe it or not, is actually similar to stress that we've covered in previous projects, in the fact that it's all about how much force you have per area. And here's how this relates to your project. We're going to be building a system that takes the air pressure out of a 2-liter bottle and transfers it to your rocket. But before we do that, we need to let you know some of the science behind it, including passing along the fact that volume and air pressure are inversely proportional, which means as one gets bigger, the other one gets smaller. Maybe you've even done this experiment before, but in order to illustrate this, watch what happens to this water bottle as we squeeze it and make the volume inside much smaller. The air pressure gets much bigger, and look what happens to the cap when we give it a little bit of a twist. That increased air pressure inside makes it go flying.